All right, this is section 8.6. We did skip 8.5. Yes? 8.4 was histograms and box and whisker plots. 8.5 we are skipping, okay? And I'm just going to give you a little bit of background information for section 8.5 because they talk a little bit about something called standard deviation. So put this at the top of your 8.6 just for some background about standard deviation. Standard deviation is really disgusting to calculate, so I don't make you calculate it, but we need to know what it means, what the standard deviation means. So I'm going to give you 2 examples, and then you will be able to see what standard deviation does, all right? So here's your first example.
Hold on.
I am going to say that the average grade on a test for your class was a 90, and to represent average, it is a symbol called X bar. So if you see that guy, X bar is used to represent the average. Average on a test was a 90 for your class. That's really good, right? Okay, really good. Let's also say that the average for the 5th period class, you guys are 8th period, 5th period class's average, we're going to say is also a 90. So on paper, you guys look like you're doing about the same as what the 5th period class is. You both have an average of 90. But now I'm going to throw a wrench in there and I'm going to say your standard deviation is 3 versus their class. Standard deviation is, let's say, 5.
So they're actually doing better.
Kind of.
Sorry.
Kind of.
I'm sorry.
Okay?
They're all getting the same.
So let's do this, okay? This is what standard deviation does. The way that I think of standard deviation, I always think of it as like a number line, where the average is the number in the middle. Okay, so both of them are 90s. And then, this is what standard deviation does. It says that the majority of your data, and we'll talk about what majority means here in a second, is within 1 standard deviation of the average. So if I add 3 to 90, I get 93. And if I subtract 3, I get 87. So the majority of the students scored between an 87 and a 93, right? Versus in the 5th period class, the majority of students scored between a 85 and a 95. So really, they have higher scores, right? They have somebody that's scoring a 95 versus you guys scoring, the top score is a 93, right? But you guys are more consistent.
Well, then I don't know.
More consistent. Okay, which equals less spread of data. So if you have a lower standard deviation, your data is less spread apart. Does that make sense? If you have a higher standard deviation, your data values are more spread apart. Yeah? That's what standard deviation does. I'm not going to go through the section 8.4 where we calculate standard deviation. It's really gross in your calculator. Big formulas. I'm not going to go through that. But this is what standard deviation does for a data set. Okay? If you take stats as a senior, we actually go through how to find standard deviation. Anyway, we go through all that stuff. Okay? But for section 8.6, they're going to give you the standard deviation. They also give you the average. Those 2 things have to be given to you, okay? Let's talk one more thing about normal distributions. Normal distributions are symmetric distributions. We had yesterday 3 different types of distributions. There was positively skewed, which actually looks like this. It's the opposite of what you think. This is a positively skewed. Negatively skewed data looks like this. Okay, and then you have symmetric data, which does like the really nice thing in the middle where everything is all in the middle. Those are really bad curvy things. Sorry, they're just really interesting here. So they're all kind of curving the same way that they're supposed to. Oh, that's still right. Anyway, so they're all symmetric data, okay? And what this really means is when the data is symmetric, that means the majority of the data values fall in the middle, okay? So like kind of looking at this middle column here, that means the average in the middle, the majority of people are scoring the average because that has the tallest towers or the highest frequency in the middle, okay? Then you have some people over here that are scoring really high, and there's not very many of them that are scoring really high. Then you have some people who are scoring really low, and not very many of them are scoring really low. So maybe you have one student that's scoring 100% and one student that's scoring a 30%. I'll let you decide who those are. But one
About
high,
that 30.
one low. The majority of the people are scoring just about average, which is right in the middle, right? Okay, whatever that value might be. So going forward in this section, we're assuming that all of those data values are symmetric, okay? If we would graph this information, that it's going to follow kind of a symmetric histogram plot, right? It's going to all be kind of the same, bounced around the average where the average happens the most often, okay? All right, so that's our assumption that we're dealing with, okay? Good? There is, this next part, there's an old dead guy who came up, legit, he came up with something called the empirical rule, and this is what you guys have that extra sheet of paper for. And the empirical rule looks like this. So what this old dead guy did, and he got thousands and millions and whatever dollars, whatever the currency was in the time, for coming up with this. But what he did was he took and crunched data and crunched data and crunched data and looked at data set after data set after data set after data set. And he came to the conclusion that based upon the standard deviation and the average of a data set, go to this sheet so that you look at this big sheet here, okay? Based upon the information that he looked at in comparison to the average and the standard deviation, was that if I have my average here in the center at the height of the bell curve, and I add one standard deviation to that, that would be like your 90 and 93, and I subtract one standard deviation, which would be 87, right? He came to the conclusion that the majority of the time, 68% of your data was going to fit between that 87 and a 93, or one standard deviation on either side of the average, whatever that standard deviation may be, right? Okay. So another conclusion he came up with after looking at data set after data set is if I add 3 more, that would be the range of 96 to 84. Does that make sense? You see what I just did? I added and subtracted that standard deviation. If our S is 3, okay? Added and subtracted it again, and what percent of the data, what percent of my students are going to have a score between an 84 and a 96? 95. You see where that's at? This grouping right here. 95% of the students in the class are going to score between an 84 and a 96, right? 68% of them are going to score between an 87 and a 93, okay? Now, if I go one more standard deviation, meaning adding that group of one more time, adding it again would be a 99, subtracting it would be an 81. What percent of the students are going to score between an 81 and a 99? 99.7%. So not everybody, because there's still going to be like maybe that one person that scores 100%, or that one person that scores below an 81. But the majority of the data, or 99.7% of the data, are going to live between those two values. Does that make sense? So you adding one standard deviation, adding 2 standard deviations, adding 3 standard deviations. Does this make sense? Okay. All right. Now I'm going to do this, just to get our feet warmed up here. Let's say I tell you I want to know what percent of the students scored between a 90 and a 93. How many students scored between a 90 and a 93?
34.
Look at that. 34. That's the percent of students. The students scoring between a 90 and a 93 is that region there, right? What percent of students scored between a 96, a 96 and a 99?
2.4.
2.4%. Does this make sense?
Will it always be those percentages?
It will always be those percentages. The old dead guy that came up with this chart came to the conclusion that if data is normally distributed, meaning that all of the average in the middle has the tallest towers, if it's normally distributed, most of the time what's going to happen is about 68% of your data is going to be within 1, 95 within 2, 99.7 within 3. Okay, that's the general consensus he gets. Now, it won't exactly be that every single time, but the majority of the time, it's going to be 68, 95, 99.7, okay? Now, what percent of the data, last question before we move on to the example, what percent of the data is below 84? 84 and below to the end.
2.5.
What?
2.5.
2.5. There is 0.1% that is below 81. And there's 2.4% between 81 and 84. So 84 beyond would be 2.4% or 2.5%. Does that make sense? You're just doing this region, right? What?
Does 99.7 plus 0.2 equal 100%?
No. You're missing a 0.1.
Oh, you're missing another 0.1 over here.
Yeah.
right?
Still
Which
up.
would only be 99.9, right? Okay, but there are rounding errors involved in that, okay? Because it's like rounded to different places, so we don't want to round up. Yeah, so it technically only entirely adds up to 99.99% or 99.9%, right? I get you.
There's
But
that one germ
but that's
left,
where the
you know?
1% falls in, whatever, you know. Yeah?
Yeah.
Okay. Because I think it's like 99.75, I think is what it actually is. Anyway, whatever. Okay? So just go off of those data values because there's rounding errors involved. All right, let's go to first example. Example 1. Normal distribution has a mean of 21 and a standard deviation of 4. I think this example, it doesn't tell you what it's going off of, but I think they meant it to be the ACT. So ACT score, the average is a 21 and the standard deviation is 4. Before I'm even going to read what we're trying to do, I put the 21 in the middle because that's where the average goes. So X bar is 21 and the standard deviation is 4. List those off to the side. Okay, that means 21 goes in the middle of your bell curve. And this would be plus 1, plus 2, plus 3. This is minus 1, minus 2, minus 3. So that means I'm adding 1 standard deviation, adding it twice, adding it 3 times, subtracting it once, subtracting it twice, subtracting it 3 times. Okay? And each standard deviation is how many units? Each chunk of a standard deviation is
3, 1.
4. They give you that, right? Yeah? Okay? So 21 is in the middle. If I add a standard deviation, it will become 25. Because each standard deviation is 4, right? If I subtract 1 standard deviation, it is 17, okay? Good? Making sense? If I add 2 standard deviations, meaning I just add like 4 more onto 25, it will be 29 to 13 to 29, right? Okay, add it again. Last one, 9 to 33. So,
we're all bad at math today.
we're all bad at math. We can't do it, okay? 3 standard deviations was that 99.7, right? So 99.7% of all people are going to score between a 9 and a 33 on the ACT. Do you know what the maximum is?
36.
36. So you have those geniuses that are out there scoring,
What if there
scoring 34, 35, 36s, and that's happening less than 1% of the time, right?
What if the
Less than 1% of the time.
doesn't happen there? What if it happens at the other end?
Then that's also another thing.
Right? Like above a 30 on the ACT.
What? Yeah, there's people.
Has anyone this year?
I don't know because they haven't really taken the ACT this because of COVID and all that stuff.
Oh, okay.
Your brother scored a 32. He did really well.
Yeah,
I
it
think
wasn't-
32
that was
is the
even above
highest.
33.
Yeah, it's not
Tanner's
above 30.
dumb.
Anyway,
Has everyone scored above a 33?
Tanner's
I don't know.
pathetic.
Sarah's gonna be the one that forgets her name and gets docked 11 points for it.
I think that is a thing. You actually get points for putting your name on.
I'll do that bad on the ACT. I'm not stupid.
Anyway.
I am.
So 99.7%. If this data is true, listen to this. If this data is true, 99.7% means that 3 out of every 1,000 people are scoring above a 33 or below a 9. Does that make sense? 99.7% means 3 out of every 1,000 people are either above or below.
Wait, how'd you get?
Would you say that there are more dumb
Okay,
people in the world?
99.7%
0.7.
Dumb people. There's way more dumb people.
means that
So,
if I would move the decimal
technically,
place 1,
one
that
out
means
of every
997 out of 1,000 are scoring within that range.
Oh,
So 3 out of the 1,000 are scoring outside of that range. Does that make sense?
Yeah.
You see how we figured that? What's that?
What is the lowest that you've ever seen in this school?
I've seen a 14.
I'll get
13.
Who did?
13?
By who?
I can't tell you that.
You told us that his brother got 32.
Anyway,
Yeah.
well, that's
What the
different.
heck?
Maybe-
I have his permission to tell people.
Okay.
Anyway.
And
So, anyway.
I'm giving you the other person's permission to tell us that bad.
No. Okay, so moving on. Find the range of values. Find the range of values that represents the middle 68%. The middle 68 goes from
17.25.
plus 1 to minus 1, right? Plus 1 to minus 1. And what are those values?
17.25.
17 to 25,
Oh.
right? So if you score between a 17 to a 25,
Where is 64?
you are in the middle 68%. You're middle of the line, 68%. You're in the middle 68%, right? 17 to 25. Okay, moving on. What percent of the data will be greater than 29? So here's 29, and they're just saying from 29 on beyond.
2.5.
Yep, 29 on beyond. If you need to look at your chart, 29 beyond is going from this spot all the way to the end. So it's the 2.4 and the 0.1 added together. This grouping, 2.5%. Does this make sense?
Why is the blue like smeared? Do you see it?
I don't know. 2.5%.
I'm sitting like this because my back hurts.
Okay, good. Moving on. All right, moving on. Top of the next page. This is the last example, and then I'll give you your homework. Okay. The heights of 1,800 students. This is how many I sampled.
Be so rude.
1,800 students. That's adults, not students. 1,800 adults. That's how many people are in my sample. Normally distributed with a mean of 70 inches for their height. How tall is 70 inches?
5 foot.
I don't even know how.
5 foot 10 inches. That's how tall 70 inches is. Okay. Most boys are like above 6 foot. Some of them, like I asked Jake Boniface how tall he was, and he said I'm 6'2".
Ah, liar.
So why
Anyway,
can't-
6'1",
He's
6'2",
6'1".
but take into consideration that this is
Yeah,
all
I'm
adults, not just
5'2".
males. All adults. So who's bringing them down?
Chicks.
Us.
Me.
Us.
Females.
You're tall.
Humans.
You're kind of tall. You're tall, right? Us. Yes, we're bringing them down, all right? So that's why it's only 70 inches. That's the average. Standard deviation is 2 inches. All right, before they even ask any questions, let's fill it out.
My learner says I'm 6'2".
70 is in the middle. Plus 1, plus 2, plus 3. Minus 1, minus 2, minus 3. Okay? Adding 1 would be 72, 68, right? Next range,
74.
74 to 66. Next range,
76 to 60.
76 to 64. Okay, now, about how many adults are between 66 and 74? So 66, 74. That's from minus 2 to plus 2. Okay? So going to your chart. Minus 2 to plus 2. I've got too much going on here.
95.
Minus 2 to plus 2. Minus 2 here, plus 2 here. That's 2 standard deviations, 95%, yeah? But here's the trick. About how many adults is that? 95%, that's true, but I surveyed 1,800. So how many does that actually make? How many is 95% of 1,800? What do you do? 1,800 times, what do you take? 0.95. How many students is that? Like 1710?
Did we do this today, geometry?
Yes, 1710. Yeah, kind of. Yeah, kind of. It was kind of that way. Yep. So 1,800 times 0.95. That's when they say how many students, okay? Part B says what is the probability. So they're actually asking for the percentage, okay? That a random adult is more than 72 inches. Okay, 72 is at this spot. It's at the 1 and beyond.
16%.
Yeah, 1 and beyond is here. So I'm looking at here all the way here. So I add all of these together. Right? 13.5, 2.4, 0.1. I add all this together, and that is 16%. So what is the probability that a random adult is more than 62 or 72 inches? 16% probability that happens.
Sarah just doesn't
Makes sense?
No, wait.
Does this make sense? Kind of ish? Okay. So you guys have a homework assignment that looks like, let's see, right here.
No, you might.
On, I'm doing this for the video, so you haven't gotten this paper yet, but there is a paper that on one side has a bell curve with a solid line. On the back side, it has cookies.
I love
Do the non-cookie side.
Did you make us
Okay.
cookies?
Do the non-cookie side. On Monday, we'll do the cookie side. Okay. We'll do the second half of the notes and we'll do the cookie side. But for now, just do the non-cookie side. Okay.